Hello everyone, this is lesson 7 and this is Mr. Chang. And with this lesson we're going to talk about function. This unit is called relation and function, and so far we have talked about relation and what is functions, right? So basically relations describe relationship between two quantities, and same for function. But relation is more general and functions is more specific. Alright, so first review. There are 6 ways to describe relationship between two quantities. And here we go, right? Graphs and all that. And then we describe domain and range, input, output, independent variables, dependent variables. In this lesson, we'll focus on the special type of relation. So some relation, if they meet the criteria, they are called functions. So what is it? Exploration. To illustrate the concept of a function, we will look at two relations that describe in words and in domain this. Okay, so restrict domain. It's a multiple of. So complete the arrow diagram is a multiple of. 1 is a multiple of 1. 4 is a multiple of 1. 4 is a multiple of 2. And 9 is a multiple of 1. 9 is a multiple of 3. And 16 is a multiple of 1, 2, and 4. So this is the relationship. And then another relationship is a square of. Okay, so 9 is the square of this and 16 is the square of 4. So what are we doing here? We are relating two sets of number. So one independent variable, one dependent variables with two different relationships. So with these two set of numbers, they can be related in different ways. One is called looking at them as multiples, the other one is squares. And you can see these are the diagram that represent the idea. Now, you can draw this mapping diagram using arrow. You can also write a set of order pairs. Now, for the first one, because each arrow will give you one order pair. Okay, complete the set of order pair. 1, 1, 4, 1, 4, 2. So just looking at all the arrows. All right. And then 9, 1, 9, 3. And then 16, 1, 16, 2, and 16, 4. All right. The first number is a multiple of a second number. But then in the second set, we have only 4 arrows. So we only have 4 numbers. The first element is a square of a second element. Now, if you plot all the orders pair, all right, 1, 1, 4, 1, 4, 2, 9, 1, 9, 3, 16, 1, 2, 4. All right, in here, you just have that. So I'm plotting those points. So just different ways to represent the same idea. So do you see that, right? The number of lines in the mapping diagram will be the number of elements in the order pairs. And then if you have 8 order pairs, how many points will you have on the graph? There will be 8 points on the graph. And here, if you have 4 lines in the mapping that's showing 4 relationships, when you list them, there will be 4 coordinate pairs. When you draw them, there will be 4 dots on the graph. Okay, so different ways to represent those relationships. Now, what is a function? A function is a special type of relations in which each element of the domain is related to exactly one or only one element of a range. If any element of the domain is related to more than one element of a range, then the relation is not a function. So, what does it mean? In the previous page, one of the relation is a function and then the other one is not. So, now, just read one more time. So for every element of the domain, for every input, if there's only one output, then it is a function. Okay? And it doesn't say the other way. It doesn't say every output have one input. It just say every input, just examine all the domain. If each one have only one output answer, that's a function. Otherwise, it's not. So looking at the arrow diagram, if each independent variable only have one arrow, it is a function. So the second one you know is a function. It's a square of is a function. The order pair, you examine if every input, okay, so I'm showing the one that is a function. So every input, 1, 4, 9, 16, they only have one output. That's a function. If you have another same input and then another, if you have another same input, let's say the first example, and then there's another output, right? Same input, but then there's two possible output, then that's not a function. And then looking at the graph, okay, you examine every input. So you look at the point. If every input, there's no other output, every x value, you draw a line, you don't see there's any other point on the same line, then it is a function. All right, so that's the concept. Okay, so it's not a very difficult concept, but you just need to know what it is, stick to what it is, that's the definition. But then you may ask, what's the significance of that? Well, we'll see that in the future. All right, why we need to like pay attention to function, like why do we need to care about function? Okay, because it's pretty much say if you have a function, it's guaranteed for every input you only have one answer. You have a definite answer. But let's look at this. Each of the following is a graph of a relation, so that's a general term. Then you can ask which one of them is a function. All right. So in here, for each input, there's only one output. Is it true for A? For each input, so look at the input, right? Every dot, there's only one value of output, so it's true for A. True for B. Now it's not true for C. How come? Because, for example, value -1, when input is -1, you could be 2. It could be the output could be 8, right? Here you can list -1, 2, and -1, 8. One or the same input, you could have two possible output. That's not a function. False. And same for D here. Just identify, for example, this point 4. You can have 4, 2 on 4, -2. All right. So it is not. For each output, there's only one input. Okay. Well, that's checking the other way around. Well, but this is not important for now. Okay. What's determined if it's a function or not is if it has only one output for each input. So the relation is a function. So just from this one, you can already tell. Okay. If also the output have only one input, we say it's a one-to-one function. Well, there's something we can talk about it later. So each output value, then you go this way. Not true for the first one, because for the output value, for example, number 5, right? There are two input that will give you the same output. So not true. True for B. Okay. Not true for C. Once you can find a counter example, that's the case. Okay. For example, value 5, there are two input that will give you output value 5. Okay. Last one is also true. But once again, this doesn't matter. Okay. So it's only the input that you care about. All right, let's moving on. And then it explains here, graph A and B. On a graph A and B, draw a vertical line. Do this line intersect the relation more than 1? Okay, so they just tell you C and D are not function as we predict A and B are function. And then we can now do something called a vertical line test. Okay, VLT. All right, it's not like the lemon tea. It's a vertical line test. All right, the vertical line test, it says it's a way to look at a relation and determine if it's a function or not. It's just a method. For every vertical line drawn on the domain, if they only cross the graph once, then it's a function. When you draw a vertical line, basically you're checking all the x value. So you're checking all the x value is it only have one output. If the vertical line crosses the graph more than once, then it is not a function. You just need one example, counterexample, to make it not a function. Okay? Alright, let's look at example, and then we'll also do the vertical line test. Okay, first, examine all the input, 5, 6, -5, 2, 6. Okay, well, with the same input, 6, 6, you can have 7 and 8. So, it's not a function. Okay, you just need one example to make it not a function. Second one, 3, 2, 4, -3. All the inputs are unique, so therefore there's only one output. Every input there's only one output. Yes, it's a function. It's a function. Yes, function. All right. Look at number C. For ABC input, they only have one line. Like there's no double arrow, right? There's only one line, so each one of them only have one output. So yes. Here, if you do the vertical line test, for this input value, whatever that is, let's say it's a 2, right? There are two output values, so it's not. So this is how you use the vertical line test. When you do vertical line test, just say this is 5, 6, 7. You're checking all the input value to see how many output there. There's only one intersection that is a function, but all you need is one example that is not, give you two output, then it's not a function. All right, next. Okay, a relation connecting the province and territories of Canada with the capital city. So every provinces have one capital city. So if the connection is between the province and the capital city, well, there's only one each. So it is a function. Yes. Okay. So by words, sometimes you need to make sure what's going on. Here, vertical line test. Every line just crosses the graph once. Okay, just keep going at an angle. So it will never cross twice. So yes. Here, I can find one example that cross more than once. So it's not. It's just a relation. It's just a relation, not function. Okay? So this whole lesson is just introducing you the concept of function. All right? A function as a map. A function set D, the domain, to a set R is a relation to which each D is related to exactly one element of R. Okay? A function from. Okay? So if a function f maps an element to y in a range, we write f map x to y. Okay, when you write f represents function. When you write f, you say it's already a function. So complete the following: 1 map to 1, 4 map to 2, 9 map to 3, 16 map to 4. So this is the map. Remember the map, right? Now we just write out the line. And this is the input, and you have the output. Consider the function. Okay, this. For a function, the input will map to this. Like this is, and any x will map to 3x plus 1. Find the domain of this. So domain means x. So when x is -1, what does it map to? Plug in -1 to here. -1 times 3 is -3 plus 1 is -2. Plug a 0. 0, this whole term is equal to 1. When x is 1, what does it map to? Put a 1 here is 4. When x is 2, you put a 2 here. 2 times 3 plus 1 is 7. So it is a function because every input is just mapped to one value. List the element of the range. Well, the range is -2, 1, 4, 7. All right. So show the function as order pair, as arrow diagram. Okay. So -1, 0, 1, 2 as mapping. I think it means as mapping notation. Okay, so I'll write down all the answer here for you. So the mapping, you need to do this for the coordinate. Just write them as coordinate pairs. Make sure you put it in brackets and comma, x and y. And then you draw the graph. Just draw the dots and then the graph. And then you see this one actually form a straight line. But you don't connect them because it's 4 separate points. All right. At this time, we label the axis and okay. So this is function, and that's it. Hope you enjoyed this lesson. And remember, a function is for every input there's only one output. Then it is a function. Have a good day. Bye.